Well, we are a digital marketing technology that uses business intelligence from online and offline sources to inform retailers to how their online ads are transacting to offline sales. So we can talk more about that, but we're not here to talk about us. We're here to talk about these guys. So we want to thank Analytics.Club for organizing, and Maria Silverheart, who's on that end, is going to kick off, and she's going to be your moderator for today. So thank you guys all for coming. Maria?
Yeah. Good. Hi, everyone. Thank you for coming. I represent Analytics.Club and the Durham Convention and Visitors Bureau. We're just working to bring more of these kind of innovative and intellectual discussions to the Triangle area. My group, my meetup is mostly networking, if you've been to them. So we want to talk about all the great other meetups and the things that are happening. So we want to collaborate with everyone. And a great way to do that is with this panel. So we're so thankful for the idea of doing that. I think it was Tasha in the Triangle Analytics Club who had suggested that. And that is Melissa's club, right? Or but you're a co-organizer as well, right?
I am somewhat involved, but not nearly as much as it seems to be.
Okay, well, sorry. Well, we want to thank the panelists, and what I'm going to do is, and thank MaxPoint for hosting, and for the food. Thank you so much. I had left these on your chair. Sorry, rewind. Melinda is sick, so she will not be here, and so I'm sorry if you came to ask questions to her, but she's very available in other meetups, and she is around, so we wish her, warm wishes so she can get better. This paper I left for you are the questions that I have compiled from what had been sent to me since the call of the meetup, and some of my own curiosities and research from other panels. Data science panels as well. So my thinking is that after I introduce the panelists, you guys have taken some time to look at these questions. How many of you have your own questions? You can just raise your hand so I can kind of see. How many people have your own questions? Okay, so we'll just run through my questions then, and kind of we can mix those in as well. I was just thinking if you had questions of your own, we could kind of go through your questions because they're more relevant. But we'll just read through mine. So I'm going to use the mic in the back, and I'm going to give you all the mic, so when the questions are asked to you, you have that. So to just start, I just wanted to have a little bio for each of the panelists. They're so interesting to me, and I'm so grateful to get to spend more time getting to know you all. I have a computer science background, so just a little bit about me. I have a computer science background, and in the last year and a half, I've been trying to level up my skills. And so I've been coming to the meetup and meeting wonderful, intelligent, bright people that have the same ideas as I do about data. And so I am just so excited to talk to you all about it, and that we're all interested in the same thing that I'm interested in. So this is great. Okay, I'm going to start with Melissa. And Melissa, I said your name was Nicewander?
Nicewander.
Nicewander, okay. That's very nice. So, Melissa Nicewander, she's a director of data science at Fidelity Investments, and she recently joined a group that does workforce analytics. In a previous life, she was a real scientist with a PhD in astrophysics and career in both astronomy and then environmental science. Thank you for being here. Jamie Dixon. Jamie has a bachelor's in arts for political science and economics and a bachelor's in science for computer science. He has a master's in public health from the University of Michigan with a focus on health administration. He started his career as a research analyst before moving over to contract negotiation. He then went into business systems development and architecture. He currently spends his time doing data science and leading a small team of software developers. His book, Machine Learning Using .NET, is due out in June 2016. Congratulations. Thank you for being here. We have also Ulrich Wang, graduate with a degree in computer science and spent 5 years developing games like Tetris World, ooh, my God, and Dark Summit for, I played it as a kid so much, right? And Dark Summit for Xbox and GameCube. He then went back to school to work on his PhD clinical psychology, dissertation in video game addiction. He works as a data scientist at MaxPoint. Thank you for being here. Marshall Markham received, right? Yes. Marshall Markham received his undergraduate degree in applied math. He went on to spend 9 years in the Army as a drill sergeant.
Thank you.
Behave, everybody. Where he learned a lot of focus and discipline, right? Chewing you out? Yeah. He went back to school at NC State to get his PhD in statistics. He joined MaxPoint a little over 2 years ago, working on optimization of digital campaigns, focused on the automotive industry. And he now works as marketing scientist at MaxPoint, developing models for store and product sales predication?
Production.
Okay. So thank you for being here. Great. So that's a little bit about them, and I'm going to do more research on them. I mean, I did a little bit, but I definitely want to do some more because it's so interesting. Your backgrounds are just so interesting to me. So I'm going to start with the questions. You all can take notes or you want whatever. The first question, and we'll kind of just go, how should we go? Maybe go down, or whoever wants to, if you guys have the mic, you can pass it around.
I can start.
You can answer all of them. You got the mic.
All right.
So, before we start, I left the data scientist kind of picture up there of the different skill sets and everything. It's a little broad, but kind of want that to replace any questions of what a data scientist is. There's so many variations. There's so much different tools and everything that's involved in it that it's really so specific to the problem and to the result and to the company and to all kinds of environmental factors and everything like that. So that's a conversation that everybody can have when they're talking about what they do and what they're interested in and how they approach it. Because I found that once I started trying to figure this out, there's no one way about it. There's so many different ways, and that's really the great thing that you can come at any angle, and there's a lot of different perspectives. So we can kind of talk about, instead of what is a data scientist, we can kind of talk about some other things that were interesting. So that's kind of up there in case you are beginning and you want to know a little bit about, or remember, like, what are we talking about? Who are we talking about again? Okay, so the first question, no matter what task, what's your data scientist toolkit? Something that you use every time there's a problem. That's always your go-to. Maybe it's a programming language or a concept or a tool or platform.
So I will go ahead and start. Can you guys hear me? Is this on? No. Do I need it? Do we need it? Okay.
It's mainly for the video recorders.
Oh, it is. Okay. It says it's on. Okay. All right. So no matter the task, what's my data science toolkit? In terms of, I'll go with concepts first, just go to the big picture first. I come in with a consultative mindset. I come in wanting to learn about the problem, figure out what are the actual problems that they're having, how can I use the data that I have to answer that problem. So in the beginning, it's a whole lot of translation, a whole lot of sitting down with the experts, the business owners, the owners with the problems, and really figuring out what exactly do they need, what testing can I perform to answer this question in a statistically rigorous way. Now, going down to platforms and languages, the two are kind of, we have lots of different platforms at Fidelity. And so depending on the platform I'm using, that's going to determine the language that I use. So we have a Hadoop cluster On Hadoop, I prefer using Hive. I'm starting to use more Spark, but I haven't been on Hadoop as much lately, so my skills are a little rusty. But I like Hive because I like SQL a lot. SQL is the language of data, and wherever I am, I use some version of SQL. So that's why I chose Hive over something like Pig. Programming languages. Those are just suggestions. Oh, sure. OK. Well, just in terms of, I prefer doing all my data munging, data preparation in something like SQL, or going a little bit lower level, working in Python. I feel like one of the, and other data scientists might disagree with me, but I feel like one of the fundamental skills of a data scientist is to be able to touch and manipulate data at the lowest level, and that requires some sort of fundamental programming language, and so I use Python for that. When I get to the modeling phase, I use R or SAS. I know you can do it in Python too, but I like R, so it's just a thing. Yeah, so that's about me.
Thank you. So as far as platforms and languages, I prefer to be in relational databases if I can, if the data is small enough, or in a NoSQL database such as Impala, if I need to get something faster. I like the SQL programming language. I've actually not used Pig. And I tend to use Python. I essentially transition back and forth between Python. I try to stay out of R so that I can sort of be fast with one thing rather than transition between a couple of things. I also try to lean on my background in statistics and mathematics when I think about things, both the deductive logic sort of nature of mathematics and the concepts of uncertainty associated, or that you learn about in statistics.
Perhaps you mentioned all that suggests use Cloudera as a flavor. Is that something you see? Cloudera, Hortonworks, MapR, sort of prevalent product camps and stuff I can work with. So I'm curious if you see more of one over the other.
So I've only actually worked with Impala, so I think you should probably take all of the statements that I make here, in the context of I've been working in data science for about a year and a half, and I'm essentially fresh out of a technical degree prior to that. I can only really speak to Impala. I can't really compare, but I think that I like Impala. It has proved to be maybe a little bit unstable, but it gets us just blazing fast speeds in the event that we've set it up for, we've set up sort of our files correctly.
Can you get this okay? Yeah. Okay. So I never thought I'd be the old guy on a panel. The first data science project was in 1992 for me, and I was downloading Federal Election Commission data over a 4800 baud modem all night for an undergraduate project, honors thing. That was in it was political science. What was in my toolkit that day and what's in my toolkit tomorrow morning will be three things. First will be my wetware. I know enough now about different languages that it's not important to me the language per se as much as the thought process behind it. And if you can boil languages down to sort of their core constructs of what they're trying to achieve, it's fairly easy to go between them, or among them, I should say. The second thing that's always in my toolkit is a pad of paper and a pencil, mechanical pencil. I use a lot of erasers. And please don't make fun of me, but that's really where I start. In fact, I think it's still pretty interesting that folks think that we need more computers in the classroom when I think we need more pen and paper, or pencils and paper. But I typically start with a piece of paper and a pencil. Again, that sort of shows how old I am. I don't know, but it helps me. I like to think things out on paper first before I go to my IDE. And then last thing is coffee. I always have coffee.
Hi. Yeah, for me, I work at MaxPoint as well. So actually, my tool set is going to look a lot like Marshall's. So yeah, he mentioned SQL, Impala, Hive is still present, and we're starting to delve into some Spark as well. Maybe some things he didn't mention were, having some Linux skills are helpful, like just because, we're doing a lot of work on servers and so forth. And I guess in terms of, stuff like if we abstract away from the actual tools, I'd say that having a background in programming and math is quite helpful. Right now we're standardizing around Python and kind of the whole notebook architecture, but who knows what that'll look like in a few years' time. And I think just having some ability to kind of generalize from that so you can be adaptable with new tools and stuff, I think is helpful. And what else? Concepts. I guess the math thing. What works for me really well is kind of just using math to kind of relate to statistics and kind of being able to then visualize what's going on. I think that's really important, at least for me, during the data exploration phase. And I guess I'm a visual learner, and yeah, that's my thing.
Great. Thank you so much. Number 2.
Just want to go back this way.
So
sure.
can you paint us a picture of what your daily routine is like? What is it that you're doing every day?
Sure. Okay, average hours worked per day. Okay.
And those are just like compiled suggestions from different people that sent me questions, so I
Sure.
can chunk them together.
Yeah, I was gonna say my boss is sitting back there, so yeah. Hey, Mark. But no, I mean, yeah, no, sure. I mean, like I usually, I roll in around somewhere between like 9:30, stay till 6 or so, and then that's kind of like
Or is there like
the hours.
tasks that you're doing every day?
Yeah, I was gonna say the tasks. Maybe that's a bit more, situational. I mean, when you look on the board there's like a bunch of 3 different domains you have up there, and I think that's kind of a nice way of kind of breaking down like what my day might consist of, like some of the components there. So, in a given number of days, I might be tasked with looking at a business problem, right? And that might require kind of a rapid iteration. It's usually more critical, I guess, that we get an answer quickly. Whereas maybe in terms of like time spent, if I'm in the middle of R&D work, trying to prototype a new model, or even like productionalizing a model, like taking something that's proven out and trying to build a pipeline around it so that it can be deployed and actively making decisions in our system, that type of timeline is a bit more stretched out. And I tend to kind of swing from extreme to extreme. Yes?
How much of your day is collaboration versus independent work?
I would say that, maybe while prototyping, it could be more independent, but I would say that, even that's kind of changing a bit. Like lately we've adopted a software development model that you've probably heard of, like Agile. And that's kind of, in my perspective, it's really kind of helped increase communication amongst teams, just because we have these structures built in, like, the daily stand-up and like sprint reviews and that sort of thing, where the team just comes together and like really has a chance to kind of voice their opinions and help with the process.
So
Yeah.
the data that you're actually analyzing
Mhm.
for which you're applying the model, is that consistent all the time? You kind of prepare the data so that your model doesn't have to change?
That's kind of, again, depends on the problem. Sometimes we have the data built up, and MaxPoint actually, we'll probably get into this a bit later, but MaxPoint's like a company that's got a lot of infrastructure, I think, maybe compared to some companies that may be smaller and like where they're still building up a lot of things. So often I'm pretty fortunate in that I can leverage just the petabytes of data that have already been collected and structured for us. But sometimes, when we're dealing with a newer problem, then you are maybe starting from scratch and have to go out and try to seek it out or kind of work with data that requires more ETL before you can use it. Yeah. Why don't I?
Let me answer a different question, so it doesn't sound like all the same. Let me do the work-life balance, if that's okay. So actually, real quick, if you don't mind raising your hand, how many folks are interested in getting into data science? Like they're wow. First off, okay, thank you. So first off, it's amazing that this many people showed up on a Friday night. Honestly, yes, it's because of you. So you've already sort of, you're recognizing that you have your regular job during the day, but then you also have to, you're continuing education. And I get this also on the software side, developing software. I mean, do you really want to go to a doctor that checks out at 5 o'clock and doesn't do any continuing education or just does the bare minimum? Would you want a pilot that does the same thing? So it's just like that with software engineering, and particularly with building applications that become more and more critical. Are you comfortable getting on the 40 with a self-driving car if that engineer was, done at 5 o'clock? It's going to be a real question, right? And it's going to be really interesting the way the regulation of our industry will go on the software development side. But on the data science side, I think it's the same kind of thing. And you're already taking the first step. You're coming out in the evenings and you're extending. But let me ask you this then. How many folks this weekend will be working with some kind of either R, Python, pick your language, I don't care, some kind of data set or analytics? Okay. And how many folks are competing in Kaggle this weekend? One. Okay, so if you didn't raise your hand on that, you might have your own project. I would encourage you on the work-life balance thing is you have to sort of figure out yourself. But if you want to break into the field, it's a very hot area. There's a lot of people going in. It's very hard for potential employers to differentiate. I would encourage you to think very seriously about what you do in your free time. And if you really enjoy working with large data sets or small data sets, more importantly, finding a problem. I do a lot with open data because I'm passionate about making our government more accountable, and there's plenty of data sets that are available, or if not, you're knocking on their door doing a public records request. And there's plenty of meetups around that, and you can pick your language, whether you want to use Python or R or whatever. So if you want to do that, that's great. Or Kaggle is probably the best way that I know that people are sort of furthering their career, because numbers don't lie. You go to Kaggle. The first thing I would encourage you to do is read the discussion boards, and then read all the scripts, and those scripts will be written in either Python or R, so you better learn to be able to read both, and then compete, and you'll see what your number is, and then you'll try to get your number better and better, and you can sort of stay with the Titanic competition, but do the real ones, and that will move you along a lot faster than probably anything else I know. So from a work-life balance, allocating, again, you have to sort of figure it out for yourself whether you're going to allocate a specific time, maybe in the mornings on Sunday or Saturday mornings when the family's still asleep or something, or in the evenings. But dedicating your time in that rigor, I think, will go a long way to, if everyone whose hands are up who are just interested in being in this, to actually doing it. I think that will help you. There you go. Mm-hmm.
So, I'll just talk about my daily routine in general. My daily routine, I have sort of created a job for myself here in a way at MaxPoint, where I was brought over to my team because of work that I was doing on the business analytics team, where I was essentially trying to pick valuable things that we could do short-term automation projects on that involved accessing our data and making decisions on it and presenting it to members of the business analytics team. So I spend a lot of time over in the marketing science area looking at things that analysts are doing and trying to make that workflow move faster. So I maintain a Python package for the team that and I. Sorry. So I sort of fluctuate between things like doing builds and making sure the Python package is well maintained and well documented, and doing more data sciencey things, doing analyses, ad hoc analyses for people, etc. Yeah.
So what will I answer? I will answer. So what I do every day. What was that?
You can do the fun parts or the not fun.
The fun parts. The fun parts are no. The fun parts are getting to do this stuff for real. The fun parts are building a model and seeing things pop that I mean, maybe it's obvious. Maybe everybody knew that this was going to pop, but you build a model on real data, a real business problem, and all of a sudden, like, you see, well, this fraud is actually occurring to these certain people, and you're able to capture that. And like, being able to do this in action for real, like, that's pretty fun. The not fun parts, lots of meetings. So I was gonna say, so the percent of time, like, I spend probably about half my time in meetings or creating decks for meetings, and no, I spend like 75% of my time doing that right now. 25% of my time I can actually like do real stuff. Like the past couple of days, I had this one task, and I'm like, it's loading data into our warehouse, and it's completely mindless, and I was so excited about getting able to just put on my headphones and ignoring everybody for 2 days loading this data. And that's kind of fun, just sitting down and coding. But really, what we do, data scientists are in the process from beginning to end, from figuring out the project, from developing what questions are you going to ask, to actually doing it, to then communicating it out. So it depends on the major projects that you're doing, the major projects you're doing and where they are in their life cycle really determine what you're doing in a day. It could be so many different things.
As a former astrophysicist and now a data scientist, do you participate in any of the NASA-sponsored data modeling and competitions about, for instance, asteroid location and impacts and stuff like that?
I have dreams of doing things like that. I have a 1-year-old and a 4-year-old. So my time spent outside of work is either trying to catch up on my sleep or dealing with them. Someday I'll get into this. So I've actually found that I have a really good work-life balance. So I go to work. If it's a pressing project, if there are deadlines, then I have no problem working extra after the kids go to bed. But normally, at least at Fidelity, there aren't data science emergencies. The website, the website doesn't go down, and I'm on some productional team that like I need to go in and there's no emergencies. So I have a good work-life balance. I'm pretty happy with it.
So at Fidelity, what kind of questions are you trying to answer?
We have tons of different applications. We have tons of different businesses that are in Fidelity. There's a lot of work around creating the best products and marketing to our customers. There's a lot of work in fraud and security. People give us their money. If we don't have the trust of our customers, then we have nothing. So we can't have a data breach. So we have a lot of analytics around that. I just joined a new team doing people analytics, so looking internally at our own employees. But we have really, data science is beginning to touch nearly every branch of the company.
Well, just to kind of continue, do you consider GIS and time and data analytics for the data scientist job that you are doing, or just as a separate job?
Would it be possible to repeat the question so that it's
So, including GIS information there are some groups that do work like that. They are not traditionally involved in the data science groups, but there are people that kind of are like specifically in that role that look at it. But we have a lot of analytics, like little pockets of analytics around the company. So it's What was your question?
Question
sorry.
on your statement about no data analytics emergencies. Isn't the security domain one area where you would get into emergent conditions where your analytics and data science is actually detecting something that needs emergency?
It would be, but then the fraud investigators would go investigate that, not the data scientists.
Not the data scientists?
Yes. Yeah. At least that's how we work.
The CFEs are calling
after you get evidence.
Okay, what was the question again? Can you say it again? So I
I think the question was, when you bring the fraud, it's different. The people who actually examine the fraud are different from the data scientists. Yeah,
Right,
I
yeah.
imagine the forensic analysis, though, is something
Yeah.
that comes on pretty concurrent with the emergent problem.
Yeah.
Okay, and the question over here?
Yes, my question is a little related to the kind of work that data scientists do. And I want to allude back to a little bit what Jamie also said, that in his toolkit he's got this web where I'm guessing that's using your brain, right?
Yeah.
So, and you can allude to the fact that you spend a lot of time just preparing written material. Right? Yeah, I think that's because you're kind of organizing your thoughts and so on.
Yeah.
Can you expand a little bit more on that? Because there's a lot of work in the programming and data cleansing and modeling aspect. But what comes before that? And can you explain a little bit more? And how important that is?
What comes before it for me, and I can hand this down to you in a second. Before it for me comes formulating the questions, making sure that we are going to do the right analysis and not spin our wheels doing the wrong thing. Making sure that I understand, like just for example, like the population that I'm going to be studying. I have to make sure that I am not only asking the right questions, but I have the exactly right population. And that often requires delving into weird business logic. And so I need to sit down and really make sure that that's right. So there's just a lot of preparation in there. On the back end, we can build models, but if we don't communicate them out and actually get the business leaders listening and understanding what's going on, then they'll never be used. So there's a lot of There's decks in the beginning, the decks at the end are all about communicating out at a level that the business folks are interested in hearing.
You are a director of data science. So you're not just in data science, right? So you're in relations with other analysts.
So I used to lead a team of data scientists. The director level at Fidelity does not necessarily have to have underlings. So I don't have a team anymore. I'm an individual contributor again on the new HR analytics team.
Army of one.
Well, army of a few, but I don't personally have any of them myself. Did you want to?
Sure. You wanted to know about sort of the wetware comment. So the thought process when I enter in particularly a new problem, and so I'll say a couple things, and one might get me into trouble. So please, we're all friends here, right? I feel very close to you. I don't think any company is particularly one tool away from any kind of competitive advantage. Picking Python versus R is sort of okay. And also, any given problem is not one model away from nirvana. So certain problems lend themselves to certain models, obviously. But before you get to that point, I'm a big believer in descriptive statistics, and I think it's because I'm not particularly smart. And so it takes me a while to sort of get my hands around things. And so I always approach it from the lowest level possible for me in my brain of what can I do with this large data set? Do I need to augment my data set? Because a lot of the times the most powerful things you get are when you start combining heterogeneous data together rather than something that's a bunch of people have already looked at. And then what can I do from a descriptive statistics point of view? Mean, median, mode, all that kind of stuff. What's the skew look like? How dense is this data? Sort of all the sort of questions that you'd go into. Then how am I going to normalize it? How am I going to do the regularization? That kind of stuff happens well before, and I do that on paper, honestly, most of the time. Maybe I use an IDE, and R is pretty good at that for looking at the graphs and whatnot. And then I start thinking about doing, quote, data science. I think data science sort of encompasses that entire process, but I think the folks I talk to, I don't know if this approaches you guys, but they just think of like, I'm doing statistics, I'm doing modeling, And there's a lot more that goes into the actual figuring out what model you're going to use and how you're going to apply it and what features you're really going to look at. So
So it's possibly iterative, but how
It
much
is.
time are you really spending on this upfront stuff versus the
Oh.
actual mechanics of the data crunching?
Oh, so you're asking like how much data munching before yak shaving before the real stuff? What's our industry? 80%? Yeah, sure, Drew. Oh, what do I use the pen and pencil for? Are you like, one second,
I
Mark.
got a pen, I had a paper and pen and paper, pencil and paper question too.
Oh boy, okay, so I sit there with my pencil and paper, and I have the domain, I write down the objects, I write down sort of the logic flow that I'm following through. I use it as a task list. A lot of people sort of put this ideas in their REPL, right, but I don't. I actually do it on the paper first before I move it over to the REPL, so. Were there other questions? You wanted to know about percentage of time of sort of cleaning, extracting data? Do you want to answer that?
How much time do you really?
Do data science. I spend a lot of time up front. Yeah, these guys.
Yes, I'd agree with that. I think that a lot of time has to be spent, if, especially if you have sort of new, untouched stuff that hasn't been, that hasn't been given to you, and already, which presumably to me means if it's already been cleaned, it's already been picked over, maybe, right? So a lot of time spent, dealing with the small stuff, univariate statistics and things of that nature.
Okay, so this is great discussion, right? We're having a lot of fun. So is there a question one of the questions here that you all would prefer to go to number 3? Because we're gonna wrap up to this. So is there a question that you all are burning in you that you want to ask out of the list? Arrow?
Something that Jamie said, distributed data and heterogeneous data sets. Does any of you actually go into linked data and actually using the semantic web to go from your data to an analysis where you're actually pulling in more data from the web? And the other question is about any of you using deep learning.
Do you want to do that first?
I mean, I guess I can address the second question. I don't think I totally understood the context of the first one. So maybe I'll let somebody else handle that. For deep learning, I know it's pretty hot right now. I think for us, like it's still kind of more in the kind of R&D phase. I think a lot of that is also because our needs are a little bit different. What we do is often very time constrained because we're kind of this real-time bidding world, and that's that certainly leads us more to kind of like maybe like simpler models, but quicker models in terms of training and scoring. Anybody else want to chime in?
Yeah.
I can talk about it. Fidelity doesn't have a lot of use cases around deep learning. I think the biggest potential there is kind of these automated financial advisors with the AI. That might be a space, but I think deep learning is so cutting edge. I think it's mostly in academia. I think a lot of businesses, I know like us, we step back and we wait and see when something is actually become more accepted, when things are more standardized, and then we'll come in and we'll use some sort of technology like that.
So just to follow up, I guess what motivates this is how is automation, things like Watson, going to affect the data scientist?
Watson.
Augmented learning.
Now being fought by the big brain instead of the human.
Yeah. Again, with kind of the robo-advisors, I think that there's potential there, but there's also so many legal issues around that as well that I don't think we're going to be there soon. But there's a lot of potential there.
Okay, we have a question right here.
Oh, well, yeah, almost. So answer my question. A long time ago, we used to prune the big data sets quite a bit. Smaller things and network things. And yet, maybe I'm looking at the wrong, because I don't understand big data. And now we've got petabytes of data, and we've got these huge
Yeah, I mean, I find that a lot of the things that I end up doing, when I'm picking through this stuff, is it really comes down to the bigger the data gets, the simpler the methods get on it. You will do a lot of with SQL even, right? You'll do a lot of just aggregation and filtering, right? Grouping, and so now you can get, you effectively can just run the same model over and over again on these small groups, right? And I've seen a number of very successful models running that way. So really, in a way, you're kind of just putting models on small data over and over again on this big data set.
Are we still answering this question?
I'm not. I don't know. I think
My question was similar to his about the training tables and number of features. You kind of already asked that. What are you doing for generalization? How are you doing model selection?
Yeah, I guess I can try to speak to that. I mean, yeah, like both your questions, you kind of talked about the size of the data you use. Yeah, I think that maybe that's one thing I can kind of link back to sort of the transition from like my academic work into sort of this big data environment. In psychology, like we're often dealing with very small data sets. Like you probably have to conduct a study. Like I had to like beg and plead, like, a few hundred people to sign up, right? And that was about all I could get. So that really kind of maybe changes the way that you try to handle the data. I guess, for example, trying to calculate how many folks I would need, I would do that up front, like do some sort of power analysis. Whereas in this big data environment, you more start from the opposite direction. You kind of have like probably way more data than you will ever need. And instead, you're probably like going to run some sort of learning curve to see where the benefits you get to adding more and more folks to your model drops off, or like kind of like plateaus. So I don't know, does that kind of get at sort of
Okay, great. A question from over here?
Yes, to follow back up earlier, so you all tend to shy away from sampling and more aggregations, or you will do sampling?
This is in response to my questions. So again, I'll caveat anything I say with I've been in data science actively for a year and a half. But I found if you get a large enough data set, a lot of the things you're running are things that I learned in the statistics program on small data sets, but they're being run over and over again on aggregations, or you have things split out in some business like intelligent way for the business, and you're running things on these smaller groups, but you're doing it over and over again, and getting value out of visualizing these different breakouts. But again, I've only been in it for a year and a half. Maybe it's quite possible that I'm missing something. This is the stuff that I've been seeing.
Do they still teach sampling in school?
Yeah.
They do?
Wow.
Really?
There seems to be kind of a conflict between sampling and big data as a
Yeah, I mean, most of the time now it's like, just look at it all.
Well, I mean
I used to have to do that, right? And then
Yeah.
that was like I don't think it was a course, but it was like a huge chunk out of a month of a class was like how to sample correctly and all the different approaches. And now it's like, now we'll just look at it all.
Yeah.
So
Yeah, but
it's
in
kinda
terms of
interesting.
number of iterations, if you need to maximize your iterations of doing things, whether it's Monte Carlo or whatever, to be able to sample this huge data set down into something where we can go, okay, let me see how many times I can run it and change a variable by a little bit each time, and okay, what this dependent variable, what can I how many ways can I do that? And once I've made those many iterations, then try to do some confirmation against the big data set.
So just it really depends on what you're It really depends on what you're trying to do. So if you're looking at fraud and you're looking at outliers and rare events, then you might need the whole big data set. If you're looking at modeling broad trends across populations, sampling is perfectly fine. And a lot of statistical techniques, adding another million rows is not going to make it any better. So, but it really depends on what you're doing. There's certain machine learning, especially when you have rare events or rare combination of events, and you're trying to determine that. That's really where the power of big data shines.
Okay, so this side of the room is a question. Okay. What are how do you
are the best techniques you use for cross-validation and in the real world? Because many times we don't have like data to cross-validate the model. Like what do you do with the
Cross-validating models.
assess the accuracy of the models?
I mean, I always have holdout sets. I mean, when I'm typically doing it, I have multiple holdout sets that I'll bring in, kind of automatically do that. Yeah.
Did anybody else want to answer that question?
Cross-validation. Actually, the only thing I'll say in cross-validation, a variety of different holdout sets is probably the most common way, is that when everyone this weekend decides to do some Kaggle then, right, because we talked about this, you'll notice that when you look at the interviews of the people who do really well there, they're going to tell you that it's not the model selection, it's not the feature selection, it's the cross-validation. So it sort of sometimes gets downplayed, but I think it's extremely important to do that. And so, like you said, holdout sets is my most common way, but I have a couple other techniques that I really don't want to talk about. Sorry.
You're saying that overtraining is one of the big risks in Kaggle competition.
Yeah, you're right. To win it, you have to overtrain. That's my understanding. But
I can quickly chime in. Yeah, also, holdout sets for sure. I mean, for us, like we have this constant flow of data streaming in all the time, so we can easily, if we fitted a model on day one, we could test it against like day two. But we also use a lot of like cross-validation through like k-fold validation, like multi-fold partitioning, I guess, of the data.
And on this side, Fred?
Yeah.
You and
So
Fred?
would you mind just take a minute to respond to that? Yeah, so I just want to mention a technique that I saw recently. He's not with anybody else, but piping. Just remembering that all the data analysis you've done in that training needs to be refit every time. So I recently attended PyData, and something that people there sort of pointed out is that people will tend to maybe do a PCA or do a standardization of your variables or something like that for the PCA on a set of means and standard deviations that then do not get refit when the new data, as the new data comes in. So I just like to point out that was pointed out to me.
Are you going to participate in PyData when it comes here into Durham?
I intend to, if I'm given the opportunity and the time.
Correct answer.
Yeah.
Quite interesting, like how to make the start from science and to the data science and the question 4. I mean,
Question
I'm
4.
very
So question 4 was biggest challenge you experienced in making your transition from science to data science.
Okay, so so I had a transition from clinical psychology into data science. I guess I kind of wanted to do it for a long time. I actually started in computer engineering, and I was kind of happy there. But then, one day I got the decision hurried along, like when I got in a motorcycle accident, and while recovering, I was like, oh, what do I want to do before I die? And at the time, it was like I wanted to maybe take a step back and do some more academic work and understand how I could have maybe more strategic value in the company I was working for, which was in gaming. And that was sort of the notion I went in with, but I didn't really know what the end product would really look like. But as I was kind of going along graduate school, there, this data science thing became pretty hot, and I realized actually this was a really great way of combining my computer engineering background with the modeling and statistics that I was learning in graduate school. So that's I kind of made that decision at that point that I wanted to kind of retarget my career in that direction. But for some of the challenges, I guess a lot of it was trying to take these two things that I think I had a fair bit of depth of knowledge in. I have a degree in computer engineering, and I'd been programming for a long time, but that still existed very discretely from the modeling and statistics I was learning in graduate school. So that was certainly a challenge, trying to bring those two together. And how do you start it? Well, for me, I think if I were to recommend anything, it would be just to kind of dive in, like both in terms of, like what I heard about, getting involved in Kaggle competitions. There's some great online courses now too. Like Coursera. Like Andrew Ng has this machine learning course in there that's actually fantastic, right? Like it's very interactive. It gives you a lot of feedback, and that kind of helps for me, like to kind of steer a lot of the, the small data methodology I'd been learning in graduate school into kind of this big data, kind of more machine learning focused world. But I would also say for, getting involved, like I think you should just like interview and try to get a sense of like what folks are actually looking for, because you can kind of like speculate and take your best guess all you want, but you won't really know until you get out there.
So we're gonna let them finish their question.
Oh, and so that was question 4, which is biggest challenge. So my biggest challenge was, I would think actually the getting into graduate school, it was pretty selective, and when I was there, epidemiology and biostatistics was pretty tough for me to get through. So for me, actually, it was just that intro, just getting over that hump and getting in. And after that, there's enough out there that has different levels of both skill set needed and different kinds of skill set needed, that the diversity, you'll find something. But as you said, just diving in and making a commitment is, I think, the first piece that you can do.
I would say that acquiring the technical skills and choosing which technical skills to pursue has been the most difficult for me. It commonly happens where on a Saturday I look at 3 books and I'm like, I'll read that one, I think. Hopefully I feel motivated today and I get some stuff done with it. I honestly commonly feel daunted by the sheer amount of material out there that I feel obligated to at least look at.
I agree with all those. I think, so I very literally went from being a scientist to a data scientist. The biggest challenge for me and what I learned during my job search was how to translate all the work that I had done as a scientist into terms that people hiring data scientists understand. So it's about translating. So I did, when I was in graduate school, I worked on genetic algorithms, creating models of these specific types of supernova. And in no way, if I had described it in the terms that I used in my papers, would anybody have ever understood or understood how it related to data science, but it totally did. So it's all about translating and then marketing yourself. Understanding the data science world, there's still a lot of hype in it. There's so much hype in it. And understanding the terms that people use, and honestly, putting those into your resume so that people know you understand. I mean, and a lot of times people doing the hiring aren't data scientists themselves, and so they only know the hype. You could be the greatest data scientist, but if you don't pepper your resume with typical data science terms, then a hiring manager would not really understand. So translation and learning how to market yourself.
Great. This side of the room.
Since everybody can hear. My name is Shoresh and I'm a scientist at Duke University. I'm in the process of transitioning from a scientist to a data scientist. I understand that we need to have some knowledge of programming languages, machine learning, statistics and everything, but my question is, how much is enough? How much of Python programming, how much of machine learning, and how much for an entry-level data science position?
Oh, entry-level. Yeah.
I'll answer it first because I have the thing. When we hire, and I've hired a lot of people, well, not a lot of people, but I've helped hire a lot of people. It is more about it's not about knowing Python. It's not about knowing R. It's about having the mindset. It's about the capability to learn new things. It's about the capability of learning these languages, because the tools that data scientists use change on a yearly monthly basis. So the things you're using now are not the things you'll be using a year from now. So it's less about, I know Spark, I know R. It's more about, hey, I've done all this really cool stuff. I've done these really cool analyses. I can work in low-level programming languages. I know how to work in Linux. You know, like there's those types of skills are more important than that.
So, so again, like I feel commonly confronted by all this stuff out there that I have to learn, right? You mentioned Python, you mentioned R, you mentioned other things, but I think the statement was made up here that 80% of the stuff that we do in data science is just dealing with the data. SQL is just such a simple programming language. Just learn that first and really learn how to manipulate data with it. And that will get you a long way. Right.
So I've got questions statement.
Okay.
Sorry.
No, go.
So the first question is, what percentage of the data would you say is structured and fits nicely into a relational database versus the unstructured data that you might get from like streaming analytics? And then the second question would be, do any of you currently or plan to do predictive analytics based on the data, or is it more summary statistics?
So I can answer that one based on some of the current work I'm doing for a big company up north. And it actually, it's funny, she's talking about HR. This one's actually analyzing developers. And so there's all this data exhaust when people write software, that when you think about DevOps and what goes through the build system and everything else. And it's sort of an untapped mine, as it were. And so they're starting to look at it to start thinking about, okay, how much of this can we take, throw it into the data lake? Better be on the resume. Does data lake have to be on there now?
Oh, I can tell you.
Okay. So it's in the data lake. So we're going to write these jobs, and then we're going to take it and we're going to put it into our rectangles, right? So we're dealing with unstructured data as the build systems are running, and we're analyzing developers and trying to sort of separate the wheat from the chaff. And then we are getting into predictive analytics because we are interested in about trying to, if you are a big enough company developing software across all of these business areas, and you have production outages, what you're really trying to do is minimize and forecast where the problems are going to be. First off, because it might be an internal app, so you're thinking, well, I'm not affecting the customer, but if you still have to hire support and everything else to maintain that application, the dollars end up pretty quickly. So 1 or 2% gain in one area can actually, that'll fund a project. So to answer your question, do a lot of unstructured data, turning them into rectangles, and yes, doing predictive analytics. Do you want to? Sure. Did you have a follow-up on that? Or?
Real fast. So you mentioned it was created by DevOps developers.
Yeah.
So what specifically things do you look for useful to you? What kind of data are you looking at? Can you give some examples?
For that specific domain, I can't speak to more than that. Sorry.
Okay, I'll go back to your question. You said, do we do predictive analytics? MaxPoint, that's a huge part of our business, right? I mean, and in terms of, it kind of ties in back to that question about, okay, how much is enough of that, intersecting triumvirate of domains. I think it might depend actually maybe on the size of the company that you're trying to get into. So for example, smaller company, you might have to actually probably own more of all the different roles and more of the pipeline. I would say MaxPoint's more of like a medium to largish size company. We have the luxury, I guess, of like a team of data scientists. And so we're able to kind of take a strategy where the entire team covers like different parts of that overlapping diagram there. So, I mean, if I were, what I would offer is that, if I were strategizing and trying to apply to a job, right, like in a larger team situation, I'd probably try to, really show off like what I'm really great at, I guess. For myself, I think like one of the things I can really leverage is that I have like a strong computer programming background. But if I were to walk in an interview, I'd want to make sure I just knock that out of the park, right? Like if they ask me a coding question, I'll make sure like I would nail that. But I suspect that type of strategy might be helpful for if your statistics is your strength. Like if someone asks you a problem, you should be able to show off all your mastery of like distributions and probability and all that stuff. Like, and whatever the business equivalent of that is, I'm not a business guy really, but yeah, there's probably something that you could do that really demonstrates your in-depth ability and knowledge.
Yeah. So also, and I wanted to go to be the fourth person on that is, so I did some software development, I still do, and and software engineering is sort of is pretty actually better than the data scientists in terms of self-promoting, and I've learned some things there that I think would help the folks who had their hands in the air that said, I want to be a data scientist, what can I do tomorrow, and what can I do on Monday, and a couple ideas that I think I can impart on you is first, there's this guy named Robert C. Martin, Uncle Bob Martin, one of the original signers of the Agile Manifesto. So you're getting into Agile. I can't remember. Someone up here was doing Agile. And actually, we're trying to bring him here to Raleigh, and so look for the meetup for that. We're trying to get him at the Hunt Library because he'll fill the room. All the Java folks know who he is, and yeah. So he says he has a series of steps you should do as a professional. One of the things that has really benefited me personally is that for 8 years, 52 times a year, every month, or every week, at 8 a.m., I would post a blog, a very short blog about a open data set, a statistical problem, a machine learning problem, a something, just to show how I think. And I picked whatever language I want. Now, if I didn't write it the weekend before, the alarm went off at 4 a.m. I don't like getting up at 4 a.m. So I made it a point, probably on Friday nights actually, to write it, just to get it done. You can go a long way promoting yourself versus passively waiting and hoping that your resume will match certain job titles. That blog has gotten me plenty of interest and work opportunities because, and you know what, when I talk to people, when the first thing I do is I don't care about the resume, I don't care about LinkedIn and all that sort of stuff. I just go see, okay, what's your GitHub look like? If you're a software developer. If you're not on GitHub, you haven't contributed to anything, it's very hard to evaluate you. You just become something in the file. But if you have a blog and I can look at it and I say, oh, this is how this person thinks, it makes you stand out. So I would think, if anything you're going to get out of tonight, if you're interested in getting into data science, I'd urge you to think very seriously about online competitions and whatever programs you're doing to differentiate yourself. Having some kind of online presence and starting and having that rigor behind it, I think will help you.
Why did you mention Robert C. Martin?
Why did I mention him? Because he has a book called The Clean Coder. And a lot of these ideas, I don't have any new ideas, I just recycle. So I'm smart enough to listen to smart people. That was my piece about it.
Okay, so question from this side, back here.
For doing data visualization on a website, Google Charts a good choice, bad choice, is there a better choice? Simple website presenting some climate data, basically. And we'll put up graphs and things. Google Charts, there you go. On your blog, how would you present data?
Oh, I actually use LiveWriter, and so I just copy from the REPL, whatever code I want to do, and if I have outputs like a chart or something like that, I'll just screenshot it and stick it out there. I mean, I'm not using like Python Notebook even. I mean, I probably should, but Jupyter, sorry.
I have on my to-do list to learn D3.
Yeah.
And I think a lot of data scientists use that for interactive plots. But I'm sure Google Charts is probably fine. Yeah. D3. Yeah. Yeah. It's a lot of people use it. It's got some very powerful. I actually.
Every company's got at least 2 tools. SAS has got like 4.
Yeah, I know. We bought a lot of SAS tools. I love SAS. Yeah. But D3 is free, and
Make sure you have IE above, right?
right. No, I don't use Tableau myself, but I'm actually about to get my group to adopt it because I've seen so many good things about it. But, yeah.
This side of the room, do you have a question?
I wanted to ask him, what Linux distribution do you use?
I'm on Ubuntu. Ubuntu. Yep.
Windows.
No, we work at the same company, so it's going to be the same.
Pass it down this way.
I mean, for MaxPoint, that's probably best answered by our HR folks. But, yeah.
There you go. We have started applying mathematical process to our personnel, looking at their backgrounds, looking at a number of pivots, trying to do some predictive analytics on the success profiles that are here at MaxPoint and the talent that's out in the market and the availability. So it's just in its infancy, but it is beginning here. And I think you're
I was going to say, I was...
We want to have a detailed conversation.
That's what I've been working on for the past year. I built predictive models around resumes. And like we just started, we just hired a new head of people analytics. And so we have a new team. We're a little bit behind in the times, but I mean, more and more big, major businesses like ours are getting into the people analytics space. But we are definitely doing that now.
Okay, this side. Go ahead.
So can you give an example of, I think Jamie mentioned saving 1% on something, and we've heard people come in, chief information officers for some of the companies handling financial data, and your data analysis is actually finding a 1% performance improvement. But can you give examples of the cost justification of data science?
So I can do this. I've given a talk where I have these numbers in it so many times. We build a model. So we have a model. What is it at Fidelity? Oh, it's adoption of a managed account. Managed accounts make us lots of money. So we want more people to do it. We want to target. If we target our marketing better to the right folks, then we know we're going to get, a certain percentage of lift in our models means that we're going to find, thousands more people to open these accounts, which means that we will get so much more money into Fidelity. And when we went from our basic model into adding in our clickstream data, looking at what people were doing on the website, and using that, including that in our predictive models, literally, it was like a 4% lift in the model. However, that translated into like $1 billion. So that justified the whole investment in moving our clickstream into Hadoop. And doing that analysis is actually really, really important. So you can't just be building models and say, oh, I made a great model. You have to be able to tie it into money. So just today, we were looking at, I was on a call looking at mobility. And so the rate that people move around Fidelity, it helps us with retention. It helps us get better performers at Fidelity. So we were literally translating, okay, so if we increase mobility by X%, that's going to increase retention by X%. That's going to save us, the number was 80 million. Yeah, it was 80 million over a certain period of time.
So the only thing I'd say to that is, when you first start out, and again, I'm talking to the folks who had their hands in the air in the beginning, because I think that was the majority of the room. You may not have a choice of where you're not going to have a plethora of offers, perhaps, though depending on the market and how good you're at marketing yourself, you might. But you can really tell companies whose management, and I think it does start with senior management, get it, or have some kind of vested interest in this versus I read in a magazine and I have to do it because my peers are doing it. And it's the same thing with software companies too. It's amazing to me how many companies are actually so dependent on software, but they have no one in senior management who actually appreciates how software is built, created, maintained, and deployed, and et cetera. So to answer your question, yeah, you have to have the numbers behind it. You obviously always under-promise and over-deliver as a general rule, and try to find companies where, from the top down, it's part of their DNA, that they understand analytics, they want to try to make data-driven decisions, and they're not just sort of playing lip service. And that's a little bit harder, but you can generally tell, actually.
Just a follow-up question to that.
Yeah.
Are there any particular industries that are more appropriate for
Oh, I don't think so. I think it spans. I used to say I used to have a couple, but I think it really. Yeah, I'm sorry. I don't mean to hold it. No, gosh, how much. It's amazing when the CEO of GM said they were a software company, and then who just said they were an analytics company? That blew my mind. It was like a farming company. I mean, when you hear that, and they're actually putting money and people behind it. Something like that, or the crop people. I'm out of my wheelhouse. But to answer your question, it's everywhere now. So I don't know, how do you separate the pretenders from the pretenders? At our level, I don't. You show up and you sort of figure it out, I guess.
Yeah, I would love to say financial services is ahead, but I can't think of a single industry where people aren't using this. And I feel like it's so dependent on the culture, the specific culture of the company rather than the industry, because literally I can't think of an industry that's not taking.
I mean, financial services are the leading edge in sort of software adoption, everything else,
yeah,
because it's tied to money.
But it's also, financial services are also technically a little bit more conservative because we don't want to lose a whole lot of money in the stock market. We don't want to lose all your money. So,
thank you.
Yes, so we are a little bit more conservative.
Great, thank you so much. I would love to say that we have one more question left, but we're actually out of time. So we want to continue this conversation. It's really great that you all came out. Thank you so much to the panelists. Thank you so much to my thank you all for coming and investing your time and learning. I'm glad to see that there's a lot of my friends here, but I'm glad to see that there's a lot more new faces here, because I think that this is a great field where all the different interests can have a collective conversation. So if you would like to continue, I've suggested, because you can't stay here, you don't want to go home, but you can stay here. So I've suggested there's Champions Bar until midnight, so we can kind of keep talking there if you like. Okay?
Where is it?
The bottom of the sheet has the address.
Oh, yeah.
Did you go to RTO?
I just kind of sit around my house and read a lot.
Well, if I see you in the hall, are you on Twitter at least?
No, I'm not. I'll probably back out here. I'll probably sit around here.
There are several different meetups that go on. If you have a meetup, you can always
sort of spending a lot of time reading books lately.
Isn't that so much fun? I love doing that.
I really do. I really do.
I'm reading a great book on quantum computing right now. It's riveting. I wish I could get the math as well as I need to. I find myself flipping back and reading again.
Don't have really a collective.
That's awesome. Yeah,
my bookshelf. Like
I'm reading less. I'm reading C.
Good for you.
Yeah.
Not even C++. You're going hardcore.
Well, I mean, so Python's written in C, right?
Yeah.
So basically,
Everything's written in C.